Okay, and it seems that we are live. Hi, everyone. Welcome to another edition of the Virtual Jug. Today, we're gonna bring a cool topic about building mobile web apps in Java with Vaadin. And with us to go over that, we have Marcus. Hi, Marcus. How are you?
Hello, doing well.
Cool. Do you mind to introduce yourself to the audience?
Yes, I will definitely do that. So I work as a developer advocate at Vaadin. I've been working with Java and the web for the past, 12, 13 years on anything from like Java EE backend stuff to nowadays more focused on front-end technologies, really just modern web stuff and mobile web.
Cool. So before we go into the presentation, Marcus, for the people that are following us, if you go to our website, virtualjug.com, you'll see there is a link that you can join our Slack channel. Maybe most of you are already in the Slack channel itself. So join the live session channel over there, and feel free to post any questions to Marcus, and I'll be happy to relay them to him so he can answer them. In the meanwhile, I would like to also send a hug to the rest of the Virtual Jug team that's sitting on J Prime at the moment. Simon, Oleg, and Ivan. We actually were live streaming their entire event on J Prime of the last couple of days, so I hope that all our viewers enjoy that as well. Other than that, let's give the word to Marcus. That's why we are here. So Marcus, whenever you're ready, please go.
All right, sounds great. Get my screen sharing on here. Okay, can you see the screen? You can see my slides now?
Yeah, we can.
All right. So yeah, thanks everyone for joining this virtual jug talk. I will be talking about building web apps in Java. We're gonna talk a little bit about mobile apps as well, like I mentioned in the topic. But really, when we're working with Vaadin, all the apps that we do will be kind of mobile first by design. So as I already introduced myself earlier, I'll just be very brief here. Working as a developer advocate at Vaadin. I've been with the company for, I guess, close to 8 years now. So I've seen it grow from very humble beginnings to where we are today. Right now I work as a developer advocate, so I'm the kind of middle person between our developer community and development team, trying to get more people to learn about Vaadin and take all the kind of feedback we get from the community back to our development team so that we can focus on the right things to build. So today we'll have a pretty short focused talk about how to build web apps with Vaadin 10. So we'll do a quick introduction to the core concepts of building apps with Vaadin 10 and what it does for you. But then we'll spend the big bulk of the time on an actual hands-on programming task where you can see how you can use Vaadin 10 to build mobile web apps. So if you're not familiar with Vaadin from before, it's a framework for building web applications in Java. Vaadin 10 is our latest version that's right now in beta. We have hopefully the final version coming out very shortly. Vaadin 10 has been a really big overhaul for us in terms of architecture. And the reason we embarked on this journey is that we wanted to get even closer to the web platform and just take advantage of some of the new features that are available directly to us in browsers so that we can kind of make Vaadin slimmer and faster and more modern. So as a framework for the web, our focus is and has always been on the developer productivity. The reason we focus on productivity is that in the end, what we want to achieve with that is a great user experience for the end users of products that are built with Vaadin. And the way we hope to achieve that is by giving developers all the tools and helpers and really good components that they need so that they can really focus on building those good apps without getting too bogged down in nitty-gritty details. Vaadin is a web framework, and we've always been fully focused on the web. That means that even though you're writing your applications mostly in Java, you're never really far away from the underlying web platform. And whenever and if you ever need to kind of break through that layer of abstraction that we provide, you can always do that. So we give you the kind of convenience and productivity of working in a typed high-level language, but you're also getting kind of all the benefits of the evolving web platform. At the core, Vaadin is a set of UI components. With Vaadin 10, we have an entirely new set of redesigned components that we designed mobile first with accessibility in mind. So by mobile first, I mean that both they have large enough touch areas and stuff to work well with touch devices, and some components, say like the date picker, for instance, will adapt itself depending on the viewport size, so that your end users will always get a kind of nice and usable experience working with that component. We've also put in a themability layer on top of these components, so you can use CSS custom properties, which are basically variables in CSS, to change the look and feel of the entire set of components in a consistent manner. The nice thing about CSS custom properties is that that's a platform feature, which means that you don't need to compile those the same way that you would need for something like SAS. All of these components that we have are built based on a new set of W3C standards called Web Components. Essentially what that means is that all the components are exposed as just HTML elements, which means, again, that you can use these together with any front-end framework that you might already be using. You could even put them on a static web page if you so wanted to. On top of the components, though, what we also provide is a Java framework that uses these components and gives you a more high-level Java API. So the end result, what's running in the browser, will always be those standard web components, but you have the option of choosing on which level of abstraction you want to use. I have a quick side note here for anyone who might already be a Vaadin user and kind of trying to understand what the big jump was from 8 to 10. So with Vaadin 8 and before, Vaadin was really kind of one big framework that included both our components and all the Java API and communication layer and everything else. So if you wanted to use, for instance, our data grid, that meant that you could only use it within the framework itself. With Vaadin 10, we re-architected this into a platform that contains two big parts. The components themselves, which, like I said, you can use together with any front-end framework that you want. And then Vaadin Flow, which is the Java API and communication layer that we use. Vaadin is an open source project. We have around 150,000 developers worldwide, and the open source community has really been one of the key driving factors of making Vaadin as successful as we have been. So before we jump into the coding itself, I want to go through just a handful of core concepts just to make it a little bit easier for you to follow along the code that I'm writing. First of all Vaadin components and all the standard DOM elements have a Java API in Flow. So if you want a button, you instantiate a button component. If you want a date picker, you instantiate a date picker. And if you want something like just a span element, you can instantiate a new span. So pretty straightforward. You can basically, just by looking at the component, you can already know its API. These components can then be laid out depending on what kind of layout you put them in. So in the previous example, these were put into a vertical layout. Vaadin contains a bunch of built-in layouts for common things like horizontal and vertical positioning. You can nest these. We also have more flexible layouts like a flexbox layout, which maps directly to a CSS flexbox, where you can build some pretty great responsive layouts without having to touch too much CSS. Now that we have these components, we of course want to building some sort of actions or functionality into our application. The way we add functionality in Vaadin application is that we listen to events. So any user component or UI component that a user can interact with will emit events on user actions. So in this case, we have a button and we can listen for its click event. And when the user clicks it, we'll show a new span with value from the text field. Any component that we have can be mapped to a URL route by adding an annotation on it. That way, the Vaadin router will pick it up and make sure that when the user navigates to that view, the right components get shown. The router itself supports multi-level navigation, so you can define parent views. You can define view parameters, so you can capture, say, the ID of a user that you want to edit and fetch data based on that. Vaadin also comes with a data binding functionality. So in this case, we have a person object with some annotations for validations. We have two text fields, one for name and email, and then we bind our form with this binder to those fields. That way, we get all the validations for free. We can also define validations by hand if we choose to, or if we want to make some more custom validations. You can also bind collections of items to components that consume them, like for instance, a data grid. In this case, we have a injected service here, and we call get people on it, and we map two attributes from that object, the name and the age attribute, to columns, and we set their headers. There's also an API that you can use if you have larger data sets called a data provider, which is basically a callback function that the grid and other components will call whenever they need more data, so you can page that data from a data source and not have to load the entire data set up front. So those are the basics, pretty straightforward. So to just sum up what we just learned, you work with components in Vaadin. You lay out these components by putting them into layouts. You then add interaction by listening to events that those components emit. And you can do all of this in Java. So let's take all of this that we just learned and put it to use and build an application. Now, the application that we're going to build is a fairly simple chat application. What it will show us, though, is how the Vaadin programming model works, how the Vaadin communication model works, and we're going to also leverage the fact that we're running on the JVM. So this is going to be a Spring Boot 2 application and using some Project Reactor stuff for building a reactive stream of messages. So let's jump into the code. Before we go forward, can you confirm that you can see my screen here?
Yeah, we see your ID. We see a browser.
Okay.
Down.
Very good. So this is my base application that I have here. This is a Spring Boot application. Nothing too special here. The only thing that I've added basically are Vaadin dependencies here to make Vaadin available. I've defined a main view, so it's listening for the empty route. It means whenever we start up the server and go to the root context, it will get triggered. And here, the only thing I'm adding is just an H1 tag with hello world. There's a little bit of configuration here on the bottom that I had to add for adding things like a service worker and a web manifest file. These are things that we're planning on adding to the framework itself, so I don't want to go through this kind of temporary workaround too much. The takeaway is that I've defined a web app manifest, which identifies this application to the browser, gives it some basic information like its name and some theme colors. It's also registering a service worker, which is something that can sit between our application in the browser and the network. And there I've cached some offline assets, basically this one static page and an image, so that if we start our application while we're offline, we can give a customized fallback page instead of having the browser just break on our users. Okay, so we'll start by just starting up this application. So since it's a Spring Boot application, we can just debug this directly. And let's hide that. Go to our browser. Refresh. There we go. So you can see we have the H1 tag we defined here, shows up here. All right, so let's start just building this app one step at a time and take it in small steps. So the first thing we want to do is just do the basic scaffolding that we need. So add that header up top with the Vaadin chat, and we'll start by doing that. For that, I'm gonna just make my life a little bit easier and add a class name for this so I can style it later. Main view, set the size of this layout full, which means that it's gonna take up the entire browser window here. And also I'm gonna set the default component alignment to center. So anything I put into this layout, I'm extending vertical layout here. Anything that I put in it will get centered by default, so that way I don't have to call center on things separately. And we'll create a new H1 tag. This, call this header. For the header, we're gonna use this theme ability layer that I'm just mentioned. So we're gonna call get element theme list, and we're gonna add the dark variant to it. And then we're gonna just add this H1 header tag to our browser, or to the main layout here. Build this, just make sure that everything is working. Spring Boot DevTools should hopefully pick up the change, and we get the header here. All right, so the first thing we want to do when a user comes into our chat is ask what username they want. So let's do that. Ask username. Have our ID, instantiate this. In here, we're just going to have a horizontal layout. Call it username layout. And in this layout, we want to do two things. We want to have a text field where we can ask for the username, and then we want to have a button to actually start chatting. Text field, username field, and then a button. So here, earlier what I did, I added the H1 tag directly to this vertical layout that we had. That meant that anything we put in this vertical layout will get just added on top of each other. In this case, I want these two fields to be next to each other, so that's why I created a horizontal layout. So what I can do here is just call username layout add username field and start button, and then add that to the main layout that we have. So build again, just make sure we're on the right track. Once that shows up here, you can see we have the field here, the button here. The next thing is adding some functionality. So we actually want something to happen when a user clicks on this button. So we'll add a click listener. And in the click listener, what we want to do is find out what the user entered for their username, and then we're going to switch over to actually showing the chat itself. So username field, get value, that'll get us the value that was input. store this in a field, username. Next thing I want to do is I'm going to remove the username layout from the main layout. Okay, we don't need to show it anymore. And then we're going to call go chat. And that's, again, a method that we're going to implement. Take baby steps. So go ahead and implement this, or sorry, build this. There seems to be a small issue with the Spring Boot DevTools every once in a while where it stops doing the reload. So I'll occasionally have to go in and restart the server. Haven't had really time to figure out what's going on there. So let's the name, hit start chatting. You can see that the layout got removed and we now have our username. All right, so let's start building the chat layout itself. If we remember from the video before, the way this looks is that we have a scrolling list of messages here in the middle. At the bottom, we have a text field for the actual message that you want to send, and then a send button at the end. So let's construct that. Uh-oh. Are you there, Roberto?
Oh yeah, you got stuck browsing?
Yeah, no, sorry, the ID froze up on me for a second there.
Yeah, garbage collecting probably.
Yeah, no idea what's going on.
It seems to be fine.
Yeah. Okay, let's see if this continues to be a problem. I'll restart the ID.
Okay.
Yeah. Sorry about that.
No worries.
Anyway, go on. Force quit IntelliJ here.
This usually happens all the time when we do demos, right?
Yeah, I mean, it wouldn't be a live demo if something didn't go horribly wrong.
Exactly. You usually have to,
Anyway.
to do some kind of sacrifice to the demo gods so things go smoothly.
Yeah. Yeah. It's, of course, a rookie mistake not restarting the ID exactly like the second before you do this. So
yeah, no worries.
Okay. I think we're up and running. Although probably still hanging from before. Let's start this up. All right, so while it's starting, let's go back to where we were. So I wanted to extract this message list into a new component. So we're creating a new component by creating a new class. And this class will just extend a plain div element, so nothing too fancy there. We'll just add a class name for easy styling later on. Message list like that. And one of the reasons I extended a div here is that I want to actually change the way this works. So whenever we call add, so whenever we add components to this, so I want to actually add the components to the layout. But then I'm going to use one of the, just kind of peek through the abstraction layer and use a JavaScript method to actually scroll down to the latest message. So if we have a ton of messages, that way we can always see the latest one. So components, the last added component, dot element, dot call function. So here, what I just wanted to show you is that even though we're working on a fairly high-level API, if we ever needed to go in to the underlying DOM API, we can do that pretty easily. All right, let's make sure this is back up and running. Yes, all right, great success. Set a width of 100% to this and add the message list, and then we're gonna create layout for the actual inputting of messages. Here again, since we want the components to be next to each other, what we want to do is create a new horizontal layout, call this message layout, and we're going to add a text field. And then button for do message layout.add. So we add both of the message field and button to this. I want the text field itself to get most of the space. So there's a handy method called expand. So I can call message layout.expand with the message field itself. So this, if you're familiar with CSS Flex layout, this basically sets a flex attribute on the field, making sure that that gets most of the space available, anything that the button doesn't need. For that to work though, the layout needs to be as wide as the browser window is. Okay, so we're gonna return that. And here again, we're gonna expand so that the message list gets most of the space available. Build this. Hope that my sacrifice is paid off. Chatting. All right, so you can see now there's an empty message list here. We have our field here, we have our button. One thing that I forgot to do here that was in my spec was I'm gonna again use the theme API that we have and make this a primary button. So that's basically just a visual distinction that's usually nice to make to your users, just to kind of highlight that this is the basic thing that they can or should be doing. If I can hide this. Okay, so now we have the kind of basic UI scaffold of what we need. Now we actually need a way of dealing with these messages. So for that, we're going to go into our just Spring Boot application here. We're going to configure a couple of beans. First one will be just the kind of message publisher. So something that everyone can post their messages to, and that will then broadcast those out. We're going to have a unicast processor of chat messages. Message here is just a POJO that has two strings, one for the username, one for the message itself, and then a timestamp for when it was sent. That is pretty simple. We just return a new unicast processor. The other thing we need to do then is create a flux. So basically something that can return several values of these same chat messages. Call this messages, and this will use a unicast processor. Here what we return is a message publisher that first of all replace the, let's say, 30 last messages whenever somebody connects. So if somebody comes late to the party, we'll kind of get them caught up, and then we're gonna have a auto connect. So whenever the first person starts subscribing to messages, this publisher will connect to the unicast processor, and that way messages start flowing. And that's pretty much all that we need for the actual backend for our simple application. We, of course, need to use them here, so we're gonna just inject them here. Call this publisher, and then we're going to have a flux of chat messages called that, and then I'm just going to store these in fields like that. All right, so the logic we want to add next is here for the send button. Whenever we click on send, we want to publish that message. So the send button add a click listener. And in the click listener, we're going to call message publisher on next and create a new chat message. Now this takes in the username and the message. So username, we put that in a field. The message itself is going to be message field.getValue. Now that we've sent that away, we can go ahead and clear the message field. And what I like to do a lot of times is also focus it. So that way the user can just go back into typing without having to manually click in there. And that's also actually something that's pretty nice from a UX standpoint to do by default. So whenever we start up, we might already want to focus this because that's really the main thing that the user is going to do here. All right, so now we have a way of actually publishing messages, but right now they're just gonna kind of disappear into the void because there's nothing listening to those changes. Also, since we added those bean configurations, we need to redeploy this for those to get picked up. So now that we've sent those out, the next part of our application is to subscribe to those changes. So we have our flux here. We're going to call subscribe on it. Subscription will get called whenever there's a new message. And whenever a new message comes, what do we want to do? Well, we want to add it to the message list here. So we're going to call message list.add. And what we're going to add here is a new message layout. So we're going to create a new component again. Create this class. Again, we're going to extend a horizontal layout because the message itself is laid out horizontally. A little pre-baked code here for a date formatter, just so we can save time typing. But really what we want to do here is, first of all, set the width of this to 100% just to make sure that it's wide enough or that they're all equally wide, rather. And then we're going to add a couple of spans. So new span for message dot. We're going to show the time first. We're going to format that with our formatter. Add a span for the username. And then we're just going to add a little colon there to separate the actual message. And finally, we're going to add a new span for actual message. So, all right. Build that, go back in here. So the way the workflow works here now, so when we click on the send button here, this will call on next on the message publisher, which is this unit cast processor. The flux here is listening to that, keeping a track of history of up to 30 of those. And then all of the clients that we have are subscribed to that. And anytime a new message comes in, we're going to add that to our message list. So see if that works. All right. Hello. Yay, that works. So that's pretty cool. We're able to publish messages. Of course, it's really kind of lonely to chat by yourself. So let's add another client here. This demo, you can see the messages got replayed. So we have our chat history here. We're going to write something and we're going to get an error. So the reason we're getting an error here is that by default, Vaadin only lets the current thread update the UI. So when this message comes in on the other client here, it's actually coming from a separate thread. So what we need to do is just tell Vaadin to perform locking. The way that works is we're going to get an instance of a UI, which is kind of the browser window, if you will. The UI has a convenience method called access, which takes a runnable. And that runnable will then get run properly with locking, and so that Vaadin knows that the UI was updated and can send the updates to the server. Okay, so let's go ahead and refresh that. This, the other one here. So let's start by just writing a message. Hello. What's the other one? Right. Hello. So you saw that the message kind of delayed. It didn't get pushed to the other client, so that's not really ideal. Right now, I was actually waiting for this client here to poll the server and see if something had changed, and that's not exactly the ideal way for us to deal with a chat application. Fortunately, it's pretty easy for us to switch over from using XHR requests to using a WebSocket in Vaadin. In fact, it's a simple annotation like this. So by annotating our route here with a push annotation, that means that Vaadin will try to establish a WebSocket for that client and go through a whole bunch of different fallbacks if WebSockets for some reason can't be established. So Marcus, I'm gonna go back here, refresh this one. Oh, and if this works, you can see the messages now actually get pushed to all the open clients. Very cool. So now we have the application more or less working. There are a couple things I still want to improve on it, just for kind of from a UX standpoint, since that was one of the things that we're aiming to do with Vaadin, is make it easy for people to build great UX for their end customers. So one of the things that's been bugging me here during the demo is that when it's asking for the username field, I always have to type in something. So maybe we can, for the demo purpose here, we can set a default value to demo, for instance. We can also, let's add a keyboard shortcut to the username layout and bind that to the start button click method. So we're basically simulating a click on the start button whenever the user clicks or hits enter anywhere inside the username layout. We're going to do the same here for the message layout. So we basically want to use enter to send messages. And here I'm gonna, again, use the message layout. That's basically the scope. Then I'm gonna do enter and then hook this up to the send button. Build this, make sure our UX improvements work. All right, so you can see we have a default value here. I'll hit enter. I didn't have to use my mouse for anything. I can continue writing messages without kind of having to use my mouse for anything. So that's really nice. Much more usable chat experience. One thing I didn't show you yet, but you might have kind of seen in between refreshes, is the offline functionality. So if I go in DevTools and make this offline now, we are showing this custom offline page that we had defined in our service worker. Like I said, these are the service worker, and the offline fallbacks and everything are stuff that we are going to build into the framework and makes much easier for you to use as the framework evolves. The manifest file that we put in there is really nice in conjunction with the service worker, because that means that if your users are on a mobile device, or these days if they're on a Windows desktop, or as of the next version of Chrome, also on Chrome OS, they can actually install this application on their home screen. That way it'll look like a native application on both their mobile device or on their desktop, even though it's a web application that you've written. The service worker will later on be able to also do things like send push messages to users if you have an application where you want to let people know what's going on. Anyway, that's a very short introduction to how you can build kind of cool applications with Vaadin. Everything that we saw there works well also on mobile, except for the one thing where I didn't want to show it on mobile, is that I didn't have time to fix the iOS bug where if you focus the chat field, the UI keyboard that iOS provides is actually an overlay on top of the web browser, so it's really hard to detect. So it was a slightly poorly chosen example by me, but hopefully you still got a good idea of how you can use Vaadin to build applications. And like I said, all the components that we provide are mobile first design, so anything you build with Vaadin will out of the box work very well on mobile. And with those PWA enhancements like service worker, it's a really good platform for building mobile applications. The source code for the demo, if you want to go through it with more time and just poke around, you can go to my GitHub and check out Vaadin chat. You might be wondering what was going on here, like how did all of this work? So let's take a very simple example. Based on what we just saw in the live coding example, you should have a pretty good idea of what this looks like in the browser. So we have a text field, we have a button, and we have a click listener on the button showing a notification. What happens is that when a user comes in, we're gonna send over kind of initial bundle of stuff, a very small JavaScript engine that kind of connects the Vaadin server to the client side, and that's able to create these Vaadin components on the client as they're requested by the server. So in our case, what we requested was a text field and a button. If I go in and change a value here, the only thing that gets sent over is that there was a click event on a button and the value of this name field just changed. So just a kind of diff of what the state change was. The server Vaadin will then kind of capture this and translate this into actually running the Java code that you defined for the click listener. So in this case, we're showing a notification. This again will get translated into a render instruction, basically saying that, hey, here are the updates to the state since last time we talked. I need you to show a new notification with the following text. So the point here is that the communication is really optimized. It's only sending over the bare minimum amount of information for the browser JavaScript to be able to construct those DOM elements on the browser. That way, it's very lightweight and efficient, even if you're on a slower network connection. let's take a look at a couple of other features that we have in Vaadin before wrapping up. So one of the really big selling points for Vaadin for a lot of developers is the automated communication. You saw that we didn't have to write REST API or any other kind of API for accessing these messages and passing them back and forth. Vaadin takes care of all of that for us. Like you saw, we can switch over from the default XHR to a WebSocket by annotating our code with this push annotation. And the only thing we need to remember then is that we need to call this UI.access helper method to make sure that Vaadin gets properly notified of the updates coming from an external thread, and that it knows to push those changes out to the servers. As of Vaadin 10, we have a much improved support for doing declarative templating as well. So in addition to the Java API that we're working with here, you can also define all the same layouts in HTML. This might make sense for some cases where you're building more like static layouts or something where it's easier to define those in HTML, especially if you're working together with, say, designers who are much more comfortable with doing the site design in HTML. Regardless of which approach you do with Vaadin 10, you still get the automated communication. You still have data binding. So it's more of a choice that you have based on your preference and what the problem is at hand. Like I mentioned, we also have this theming layer built on top of all of the components that we have. This comes with both a dark and a light variant that we used in our demo here. And like I mentioned, it's also customizable by using CSS custom properties for things like border radius and basic colors and spacings around components. The nice thing about setting these CSS variables is that they apply to all the components in our component set, which means that if you change them, you will always kind of end up in a consistent looking set of components, not risking having like the text field looking out of place with all the other components. With the new set of components that we built, we put a lot of effort into accessibility. So we want to make sure that all of them are usable through screen readers and other assistive devices. So you can be sure that all of your users are able to use them. And if you're building software for industries where you have governmental regulations or something mandating that you have good accessibility on your site, this is, again, one of the things that will really improve your productivity, since you can get a whole bunch of functionality out of just using the ready-made components that we provide. One of the kind of main drawing points to a lot of our customers, especially in industries like banking and finance and insurance and industries like that, is a strong security foundation. Especially if you're using the Java API on the client side, you're starting off from a very good point of view from a security point of view, and that's because in that case, none of the application logic or state is really exposed to the browser at any point, only what's needed for a particular view. It also takes care of doing sanity checks, like making sure that nobody's triggering click events on disabled buttons or trying to access something that's not visible on the screen. So you get a very kind of solid foundation for building secure applications. Vaadin has had a very stable API throughout its history. We've actually been around since around 2001. And the API for many of the components is still very similar. And the reason that it's so similar is that the Java API is pretty high level. So on a functional or conceptual level, something like a button doesn't change all that much over time. So it's still an element that you click on and something happens. Having this strong separation between the Java API and how we implement that API in the browser has really allowed us to keep Vaadin up to date as the browser technology evolves. So just with Vaadin 10, we migrated from having our components, UI components written in GWT, to having them built as standards-based web components without having to change the API too much. There were some changes with Vaadin 10, perhaps bigger than with some of the other ones, just because we wanted to simplify the API and get it closer to the web API to kind of give our developers more access to some of the cool new platform features that are available. And really, one of the main strong suits of using Vaadin for building your applications is that it's running on the JVM, which in turn means that you get access to all the ecosystem that comes with it. So you could write your applications in Kotlin or Scala. You could test your code with JUnit. You can use your favorite IDE that hopefully doesn't crash as mine did. You can use all of your favorite Java libraries and so on. So it's actually running in Java on the JVM, and that gives you everything that the Java ecosystem has to offer. We take a lot of take care of making sure that Vaadin works in all the different browsers that we support. We have a bunch of nightly tests running all the time just to ensure that browser compatibility of our components is not something that you need to worry about in your projects at all. Kind of touched on this earlier, but we also wanted to make sure that Vaadin is extensible. So even though we come with a very big library of components and we can handle a very big set of use cases through those, we understand we can't really solve everyone's problems with the core API. So instead, we made it really easy for you to pull in any existing components or create your own new components to Vaadin. The benefit of having a pretty large open source community is that there's a lot of these components already created by community members. So you could, for most use cases, you might already be able to find a ready-made component that you can use instead of having to create your own. One of the ways that Vaadin does make money is by having some commercial add-on components for specific use cases. For instance, for charting, visualizing data, we have a tool called Test Bench that allows you to do end-to-end kind of browser-based test of UI. So you can assert that certain things happen in the browser and actually exercise the entire Vaadin application through that in your unit tests. We also have a new visual designer where you can drag and drop design UIs if you're more inclined to building your UIs in a visual way. This is great, especially for those use cases where you're building very large forms or some other kind of big static pages where it's just faster to crank them out by dragging and dropping or copy pasting. So to just conclude really quick, with Vaadin 10 being a slightly larger change in our product line, we're also moving to a faster release cycle, meaning that we're targeting to have around 4 major versions of Vaadin coming out every year. But every so often, we'll have a long-term support release coming out, which allows our enterprise customers to kind of jump from long-term support to long-term support, enjoying the 5-year support that we've always had for our releases. The following things that we have on our roadmap once we get Vaadin out and shipped is building better support, like even better support for building progressive web apps and really the next generation mobile web apps. We have a bunch of new components in the pipeline and some more application starters in addition to the ones that we already have to make it really fast to bootstrap any kind of new project. So yeah, if you ever need help with building a Vaadin project, you know who you can get in touch with. We've been around, like I said, for about 17 years, helping developers build web UIs using our open source projects. We're originally a Finnish company. We have our offices in California as well, where I work, and one office in Germany. And as a final piece of trivia here, Vaadin is the Finnish word for a female reindeer. So that's where the logo comes from, if you've ever wondered. Here are some links that you can use if you want to learn more. So you can go to vaadin.com/start to see the starters that we have and links to tutorials and stuff. You can also find us on GitHub if you want to just check out the repos themselves and see like how the code actually works. And if you want to chat with us, you can join us on our Gitter channel. There's also a forum on our webpage that you can use if you prefer to do that. And that's it. I'll hand over back to you, Roberto.
Thank you, Marcus. That was great. I mean, I think you gave like an awesome talk over there. You showcased some pretty cool stuff over there. And it definitely brought some curiosity on me to try some of those things out on my own. So we have a question here on Slack.
Yep.
So when you were doing your code demo, there was a place where you typed in some JavaScript that was to scroll down
Yes.
the screen. I believe that you're also able to actually code JavaScript functions directly, right? Or any other?
Yeah. So this call function. So when we call get element on any Vaadin component, we actually get the underlying DOM element or its Vaadin representation, and then we're calling a function on that DOM element. So that's essentially calling a JavaScript function. It will run in the browser.
Okay. So and the question from Frank is how are you able to debug this JavaScript code that you have over there, the one that you inline on the Java code itself?
So all the Java code is running in the JVM. So that since I started my application in debug, I can debug all of that code there. For these call function and stuff, those should really be kept to like the one-liners that are here, so you can figure out if they're the ones breaking. If you're building, like I said, we have the template API. You can add some JavaScript, like actual JavaScript functionality in there if you're building some more complex client-side logic. In that case, you can debug that JavaScript just normally through the browser dev tools.
Okay. Also, when you were showcasing some of the additional features, you mentioned HTML templating.
Yes.
Right. But I'm guessing that for doing all the wiring, event listening, and so on, you still require Java code, right? How would you link the Java code with the HTML templating?
So the way that works is that for any HTML template you do, there's a corresponding Java file that defines a model for that template, and that model is basically a Java interface. The way you then communicate is you can set values in that interface. They will get automatically sent over to the client, and you can bind to those in the template. If the template wants to call a function or update a value, we have a way of exposing methods in the Java class so that you can call them directly from JavaScript. So there's a kind of two-way communication that you can work. There's a really good documentation in our docs for how to actually do that in code.
Okay. We actually have 1 minute left. We don't have any more questions, I guess. I mean, if there is anyone that wants to post any questions, now it's your time on Slack.
Yeah. If not, you can reach me at Marcus Hellberg on Twitter, or just head on over to our Twitter that I posted here, and I'll be happy to answer questions like throughout the day and in the future as well.
Yeah. So let's wrap this up. So Marcus, it was a real pleasure to have you here with us. Thank you so much for joining me. I hope that you.
Yeah, it was a pleasure.
Yeah. So we're gonna have a next session for next week about Jenkins. So please make sure to check our meetup website and sign up for that. Other than that, let's wrap this up, and thank you so much for joining us, guys. We'll see you next time. Bye bye.
All right. Thanks. Bye bye.